Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, so this video is to cover about ellipse. So the first thing that we need to know in ellipse are the components that we have in ellipse. So as we can see, here is the example of a horizontal ellipse. Okay, so ellipse will have two major things which are the axis. Okay, as you can see, one of the axis is longer than the other. The longer one, which are in the orientation of horizontal, is called as the major axis. Okay, the longer one is called as the major axis. Meanwhile, the shorter axis, which is in the vertical, is called as the minor axis. Okay. So the major axis, the total length of major axis will be equal to 2a, and the total length of minor axis is equal to 2b. So that's mean from the center, which is at the middle of the ellipse. This is the center at the origin. So the center indicates the middle point of the major axis. So that means we will have a length between center to the vertex of the ellipse will be equal to A. So the other side will be equal to A. So total will be equal to 2A. So meanwhile, for minor axis, from center to the minor vertex that is located up here, the length will be equal to B until center. And from center to the another minor vertex at the bottom is also equal to B. So it will bring up a total of equal to 2B. Okay, so from this major and minor axis, we will have a major vertex right here. This is called a major vertex. So I want to label it as V2 because we will have a V1 right over here. So V1 and V2 is called as the major vertex, and V3 and V4 is called as the minor vertex because it is on the minor axis. Okay, so from that, for ellipse, we will have two focal points already labeled here. The F1 and F2 means the focal point. So the length from center to the focal point will be indicated by the letter C, and as we can see here, we will have a right angle triangle that is from the V3 to the center and from V3 to the F2. So here is our right angle triangle, and the length from the V3 to the F2 is actually at the same length with the length of A. Okay, from V3 to F2 is at the same length with the length of A, which is the half of major axis. Okay, so from that we will have the equation of the right angle triangle. We produce a Pythagoras theorem. So we have C square plus B square equal to A square, and we have C equal to A square minus B square square root. Okay, this value of C is very important because it will help us to determine the position of focus. Okay, so besides that, we have another thing which is called as the latus rectum. Okay, the latus rectum is a line perpendicular to the major axis that passes through the focal point and ends when it intersects with the locus of the ellipse. So these are the latus rectum. Okay, also on this side. Okay, the formula to calculate lattice rectum will be equal to 2b square over a. So this is 2b square over a. Okay, now let's look at another type of ellipse. So I use from the same picture from before, but now I rotate it so the ellipse will appear vertically. So this is the y and this x-axis. So I would like to call this as a vertical ellipse. Okay, so the vertical ellipse now will have a different label for major and minor axis. So this is a short one. Short axis, so it will be the minor, and here will be the major axis. So now, since we have different kind of minor and major, so the formula for minor axis now will be equal to 2a, and the major axis now will be equal to 2b. So it depends on the position of the ellipse. Alright. Okay, so now from the center, we have the center here. So from the center to the focus point, okay, as mentioned before, the length from the center to the focus point will be labeled as C. Okay, and the length from center to the minor vertex right here, minor vertex. So now V2 will be a minor vertex because it is on the minor axis, and this one will be labeled as A. So that's mean the length from major vertex to the center, major vertex V3 is equal to B. So that's mean we will have the same length of B right over here from the focus to the vertex 2. And now we will have different formula for C. Our C square plus A square equal to B square. Now C will be equal to B square minus A square, square root. Now this is the value that you use to find focus point. Okay, the F1 and F2. So for the summary, we have two kinds of ellipse. One that appear as horizontally and another one appear as vertically. Alright, so both ellipse, horizontal and vertical, shares the same equation, that is x square over a square plus y square over b square equal to 1. So this is the equation standard form for ellipse. So how can we determine whether the equation actually represent the horizontal ellipse or the vertical ellipse? Okay, since both ellipse share the same form of equation. Okay, so as we can see, we revise back the value of A. So this is the major. Okay, so then this is the length of A, and this is the length of B. So as you can see here, the value of A is bigger than B for horizontal. And meanwhile, for a vertical ellipse, this will be the A, and this will be the length of B. So you can see B is bigger than A. So when A is bigger than B, where A is bounded to the X, so then we will have a horizontal axis. When B is bigger than A, where B is bounded to the Y, so then we will have a vertical axis. Okay, so now let's look at an example. Find the foci, vertices, and length of lattice rectum, major, minor axis for ellipse x square over 9 plus y square over 4 equal to 1. Okay, so here is the equation for the ellipse. So what the first thing that we need to do is identify the A and B and C from the equation. So the form of the equation is x square over A square plus y square over B square equal to 1. So that's mean A square equal to 9, then A equal to 3, b square equal to 4. So b is equal to 2. So this is our a and b. So which one is bigger, whether a or b is bigger? Okay, so since a is bigger than b, okay, 3 is bigger than 2, so a will be the major and b will be the minor. So that means we will have a horizontal axis. Then we have to find the value of c. Sorry, not horizontal axis but horizontal ellipse. So to find the value of c, c square plus b square equal to a. So c equal to b a square minus b square square root. So c is equal to square root of 5. Okay, so now we have a, b and c. Okay, so now let's sketch the ellipse. The center of the ellipse for now will be at the position of origin, and it will be appear as a horizontal. So here is the center at 0, 0. Okay, so we want to determine the position of vertices. So we will have two kinds of vertices. First is the major, and another one is the minor vertices. Okay, so let's first do for the major. Okay, so now we already have the length of a. So the length of a right here will be 3. A equal to 3. So the position of the major vertex on the right of the ellipse will be equal to 3, 0. And on the left side, it will be equal to negative 3, 0. Alright. Okay, then for minor vertices, the length of b is equal to 2. So the position of vertex here will be equal to 0, positive 2. And down here will be 0, negative 2. So here are the 4 positions for vertices major and minor. So the next thing is to find the position of foci. Okay, so foci we have the length of c is square root of 5. So that means from center to the position of focus will be equal to the length of square root of 5. So we will have foci at coordinate of square root of 5, 0. And on the left, it will be at negative square root of 5, 0. Okay, so that is the position for foci. And now we want to find the length of latus rectum. So latus rectum will be equal to its formula, which is 2b square over a equal to 2 square over 3 and equal to 8 over 3. So that is the length for latus rectum. Okay, now we want to find the length of minor and major axis. The length of minor axis will be equal to 2 multiply with the value of b. So that is equal to 2 and equal to 4. So then the length of major axis 2 multiply with 3 and equal to 6. Okay, so now we have one more example for ellipse. So given the equation 11x squared plus 5y squared equal to 55. So we want to find the vertices and foci for this ellipse. Okay, so firstly, this equation is not in the standard form of ellipse. The standard form of ellipse, it must be equal to 1. So in order to change the right side equal to 1, so we must divide it by 55. So it will be equal to x squared over 5 plus y squared over 11 equal to 1. So now this is the standard form. So from here we can continue to determine the value of a, b and c. So a equal to square root of 5, b equal to square root of 11, and c we depends on the equation, so that will be b square minus a square square root, and it will be c equal to square root of 6. Okay. Alright, so as we can see here, why do I use the equation of c equal to b square minus a square? Because the value of b is bigger than a. So here is the major and here is the minor. So that means our ellipse is in the form of vertical ellipse. So that's why b become the major of the ellipse. Alright, so let's sketch the ellipse first. Okay, here is the axis. Alright, here is the center at the origin, 0, 0. And we want to determine the vertex at major. So here is the vertex. Okay, given that the length of b, so this is the length of b, is square root of 11. So our location or position for this vertex will be 0, square root of 11. And meanwhile, the vertex down here, it will be 0, negative square root of 11. Alright, and the vertex at minor axis, it depends on the length of a, and a is square root of 5, so that will be square root of 5, 0, and on the left side, it will be negative square root of 5, 0. Alright, so that is the position of our vertices. And then now let's determine for the position of focus. So this will be the focus. So focus depends on the square root of 6, value of c. So here is the square root of 6. So our focus will be 0, square root of 6. Okay. And then the down here, the focus is 0, negative square root of 6. Alright, so now we have done for the vertices and foci and sketch this ellipse. Alright, so next example, we want to find the equation of an ellipse given the vertices and foci of the ellipse. Okay, we can see the equation of ellipse, it must be x square over a square plus y square over b square equal to 1. So what we need to do is to find the value of a and the value of b. Okay, so given that the vertices of an ellipse are positive and negative to 0, so we can see positive and negative 2 is the coordinate for x. This is the x-axis. So that means the vertices, this question mentioned about the major vertices. Okay, so given it will be at negative 2 and positive 2. So we know our ellipse is a horizontal ellipse. So this 2 actually means the value of a. So we have a that is equal to 2. And the foci that will also be on the major axis is at position of 1 and negative 1. So we have c is equal to 1. So what we need to find is the value of b to be inserted into the equation. So now we use the formula of c. Use the equation of c square plus b square equal to a square. So b square equal to a square minus c square. Now we will have b that is equal to 2 square minus 1 square square root So b is equal to square root of 3. So now we have a and b. So we can insert the value into the equation. So our equation for the parabola is x square over 2 square plus y square over 3 equal to 1, or over 4 plus y square over 3 equal to 1. So this is the equation of the ellipse.